Okay, so let's continue with this following the textbook. I'm not sure I really like the textbook. How many of you read the textbook, follow the textbook? What do you think of the textbook?
Which one? We have two.
Oh, the second one, the Multimedia Systems one. So she'll be here. She'll be here in like a month and a half or so, right? She writes a lot of books, and unfortunately or fortunately, that's the only book I can think of that covers something vaguely related to this topic, right? Ignoring the editorial stuff, it doesn't seem to follow some kind of a theme, right? It repeats itself, and it refers to the other stuff. It doesn't look like a textbook. It says more stuff like, in some book or some paper, they say something like that, right? So it expects you to have read that particular paper before you can proceed, kind of stuff, right? Unfortunately, fortunately, that's the best book we have. So I'll try to add some stuff and try to go from there. And by now, most of you figured that I'm not a big fan of like the work which happened just a few years back. So we'll try to do the best with the kind of books that are out there. So the topic we want to cover today is the notion of a media server. How to serve the contents, and that involves some amount of networking. We'll look a little bit into that in the next lecture. Essentially, you're trying to serve your content to a large number of users, and the challenges involved in that are there are a lot of challenges, right? So there's the issue of how do you serve the contents to all your users? How do you make it scalable? Especially if you're stuff like YouTube or something where you're serving to a lot of people. How do you make that scalable? How do you make sure that people don't steal those things? That's one of the great things going for YouTube, right? They use Flash. So essentially, how do I control what you get to see? How do I control the quality that you get to see? How do I control based on what you're capable of, based on what I'm capable of giving you, and so on, right? And all this involves money. So there's a money component which we're not talking about. So YouTube is apparently sort of free, but other media servers, other media objects want to give different service to different people. So how do you figure out how much to charge you? What's the quality that you get? Notions like that. In general, there are two ways of making this content. One is the push model, one is the pull model. And push model is more of like your TV kind of setup, where there's a channel where the movie's always coming through, and you join a particular channel and you listen to the content. And you can think of that as like broadcast or multicast. And there are also subtle differences. Some of the push model that people have looked at doesn't necessarily involve like a TV model. It sort of feels like a pull model, right? Pull model, you go to a website and say you want to watch a movie, and it starts streaming to you. Whereas a push model, I decide when the things go out. And there are hybrid models where there's constant channels going through. You kind of join in. Whenever you join in, you kind of slowly merge in with the existing channels, right? I don't know if we'll have time to go through those kind of models in the research paper section, right? Essentially, you make a scalable broadcast. You have multiple layers. Remember the layers we talked about in the MPEG encoding, right? So I keep broadcasting different layers all the time. So when you come in, I give you a little bit stuff directed to you, and then ask you to join the existing stream. So eventually you'll be caught up and you'll look like you are doing a push model, right? You can join anytime, and I kind of nudge you towards the existing channel, right? And those sort of stuff are, again, they all depend on what kind of application model that you're looking at, right? How many of you have Comcast cable? I heard Comcast has a.
I know. I'm just laughing because I have just a little rabbit ear on my.
You don't count, right? So how many of you are in the in a fashion where you can download content? The voice, video on demand stuff, right? I think Comcast has a video on demand, right? Because Chris loves that. Chris Paulabor.
Well, I actually really like it too.
Okay.
It's really cool.
Okay. So, how many of you know what that's about? So the idea here is it's a pay-per-view, right? Except you can join any time, right? Pay-per-view in the old model, the popular movies are broadcast every 15 minutes or so, and then the other ones are broadcast in different channels. Here you make a request and then it starts, right?
But it's not just pay-per-view.
Okay.
Like they have any show that you get, right, or any channel I should say that you get, you pretty much all of them have a section. And as long as you're paying for the channel, you also get access to the content from that section.
Okay.
So, for example, Discovery Channel, right, has like, not all of their shows, but has maybe 20, 30, shows that you can start whenever you want. You can pick which ones you want to see.
And you don't pay extra for the...
You don't pay extra.
Okay.
As long as you get the channel.
Okay.
As long as you're paying for the channel, you get the corresponding on-demand stuff. They have pay-per-view too.
Okay.
It's not that they don't have
okay.
But it's not just pay-per-view.
So this is not like the DVR, where you have your own recorder at your home.
No, they're streaming it to you as you request.
Okay.
So your server is playing it, and when you want it to pause, you hit pause, your machine tells their server to pause.
Okay.
Pauses. So whenever you pause or fast forward or whatever, you hit the button, there's a second or two delay before, worse than the old VCRs, right? With delay before.
And your set-top box does not have a hard disk?
No.
Okay. So, how many of you used this feature? I don't have Comcast, so have you used? So essentially, that's video on demand. The cable companies and TV companies have been threatening to bring video on demand for a long time, right? So essentially, you can seemingly choose a program that you want, and then it streams content to you, right? And given the state of the bandwidth that we kind of alluded to so far, if all of the customers start to demand content, start to pull content on demand, right? They don't have the bandwidth to support all of you, right? So they have to do smart things. So it looks like a pull model where he gets to feel like he's requesting a thing, and then it starts to come to him and only him, right? But they can do other stuff to make him join existing. So you keep broadcasting some constant stuff, right?
I don't think that's what they're doing. I think they literally right now, if everybody in the neighborhood were to hit play in a different movie, I don't think they could support it.
They don't have the bandwidth to say what you're saying. So they must use something smarter, right? They don't have extra bandwidth to let everyone stop on the fly or play on the fly, right?
I think they did the
but the bandwidth is still limited.
You'll notice sometimes if too many people are on, you can't access it.
Oh. Okay, so if you...
so you could potentially streaming specifically for you. It's not like, because they have these concepts of local nodes for Comcast. That's how they do the cable ones too. So one node will serve like, 40, 50 homes. And so literally, everybody in the 40 or 50 homes, we're trying to use the service. They don't have the bandwidth to support it. They just tell you.
Okay, so that's a non-scalable approach, right? I mean, you can't basically have more than one channel, right? But you can do scalable approaches where they can do smarter. I mean, people have been doing research on this for a while, and hopefully Comcast would use that, because the way he was describing is non-scalable, right? So essentially, suppose each of you is a video on demand customer. Each of you want this channel on the when you require it, right? Then I need to have that much bandwidth to give to each of you. I need to have a separate channel for each one of you to stream. And cable, they don't have the channel that bandwidth, right? So one way to do that is to block off people from requesting when things are very popular, which seems to me like a dumb way to go about it. The other way is to do something smarter, right? Where I cannot figure out how many of you are requesting. So all these schemes, if all of you request, the different programs at the same time, then none of the schemes would work, right? But if two of you are requesting the same thing, then I can sort of multicast. But it's not the simple multicast, because then you may have started at different times. So I need to kind of tell the player who started later to start buffering some of this content that I'm sending to the other player, and then eventually catch up, and then play games, right? So I have no idea how much of this Comcast does, right? But that sounds
They
kind
don't
of
do any of it.
okay.
But there are other services that there's somebody who's now selling a set-top box where you'll have a different 200 movies on it every month because they'll stream it to everybody.
Okay.
And but your server will just sit there and store them, but you can only access whatever's on it. They're storing it all on their side. There's no storage
On the client
the
side.
local box.
Okay.
There's no storage, so it can't do any of these things.
Yeah, even if they have memory, that's fine, right?
But they don't have enough memory. There's nothing like that. They have a DVR box that has it.
Yeah.
But
Okay. So, as you can hear, there's a lot of different variations of this model. Yes.
So I agree that's not very smart. But if you don't know when anybody's going to ask for a loan, you won't be any smarter than just
So there are some cases where you can't be smart, right? So if all of you request a different object, then I can't do anything smart, right? Because I just need to give you all the contents. But if two of you are requesting the same, content time shifted, right? The cable works on the model that there are more than one people interested in the same object at the same time, right? If everyone is interested in different contents at different times, then cable TV in general would not work, right? So if they believe that model that everybody is interested at the same time, but they are letting you time shift, then it can work, right? So you're interested in a program and somebody's interested in the same program, but they started a little bit later than you, then you can do something smart, right? Then you can say, now you're starting, but she's already listening to this stuff. I'm sending it to her. Start recording all the packets I'm sending to her, right? You're not going to be able to play it because you haven't come to that point in time, right? You started 15 minutes afterwards. So start recording everything from what I'm sending to her because it's all broadcast channel, right? And I'll send you specifically the first 15 minutes of the program. But then once you are done with 15 minutes, then I don't have to send anything more, right? So that way I can support two people by transmitting the contents plus 15 minutes extra, right? So you can do something smart like that, right? I mean, obviously, if all of you are listening to different channels, then the systems cannot scale, right? But if that's the case, then the whole cable TV would not work.
they don't have commercials. They have
So Discovery Channel, they remove all the commercials?
instead of having 5 minutes of commercials, they'll put in one Discovery Channel. You can skip through the commercials, yes. But frankly, I wouldn't bother because by the time you hit fast forward and then play again, with all the time lag. But realize this isn't you don't have all the shows.
Mm-hmm.
In a given month, they'll pick 20 shows that you can watch, and that's what you got.
So actually, going back to this one of the smartness, right? One of the smartest thing you can do is hard disks are cheap, right? So you can actually kind of pre-populate all your hard disks, right? When you're not doing anything, just pre-populate this contents, right? And that way, if you asked it, then you can actually send it to all the people, right? These are more research projects. One of the other things that people do is you do user studies to figure out how much people watch these things. So if you notice that people only watch the first 15 minutes of a content, so just preload first 15 minutes to every machine out there, right? And then afterwards I can patch it as you go along, right? So there are a lot of research projects, and they've been doing this forever. I mean, when I was started my grad school in '93, they were doing user studies and trying to get this going, right? For some reason or the other, it was not catching up. But I think now there's more, at least some notion of video on demand on Comcast. I don't know how powerful it is, but it's still a little better than the other stuff, right? Yes.
I was thinking about playing this summer where every person had a little screen on their seat, and you could choose between several dozen movies and shows.
Was it JetBlue or something, right? Some of the. Okay.
Can you start the movie?
Oh, really?
Yeah.
Because the ones I upload in, they have
10 VCRs somewhere, or 10 DVDs, and just put the movie on each one of them.
You can pick which movie you want to see, but
they'll run simultaneously, and then once they finish, they run them all over again, so you get to a different movie to watch.
The Boeing 777 ones, that's true video on demand, right? It does these things, it does these things to patch up the stuff, right? But there's also, I think, like JetBlue or something, which actually runs TV on.
Satellite TV on.
Yeah,
Oh, really?
all the stuff.
JetBlue does that.
And that's not a smart thing, right?
It's not a smart thing?
No, I think it's just putting all the channels on different channels. I don't think it lets you freeze and rewind, right?
No, but you get to like watch 30 channels in an airplane when you used to just watching the movie, as it was back in the old days. So I think I enjoyed it. But
yeah, so one of the things that like all the airlines, I think the 777s can actually do the freeze and play, start anytime, not just on the first class but also on the retrieval class, right? So they could do a whole bunch of these things, but they're trying to cut down cost, right? So the cost, I was told, is not just on the video gear and on the screen, but also on the cabling, right? Because apparently the cables are pretty heavy, because they're trying to cut down on fuel, so the cables are something that they like to get rid of, right? So Delta is actually working really hard to go wireless on everything, right? All commands and all of their, not just for the movies and stuff, but also for the controls and everything, right? They want to go 8 to 11. What?
Cables are expensive. They're thinking about doing that one of my friends is researching that for the auto industry, about changing all your micros in cars and wires or something.
Yeah, in here they also worried about the weight, right? So it's a long running, the gas thing. So Chris Polivar's advisor actually works with Delta on making them all wireless, right? It seems so scary because they've been telling us that you turn on your cell phone when it's taking off, it's going to fall off or something, right? But which never made any sense to me. But
well, actually, it's not true. It doesn't interfere with the communication with the navigation system. It conflicts with the communication system on the Earth. It doesn't do anything to the navigation system. Yeah. But apparently, it's not very nice to say navigation. It sounds like more important to say navigation system because people think you're going to crash. Well, as you can actually monitor the frequency with somebody's talking.
Forget about cell phones, right? But if you use your wireless laptop and something, you're not supposed to use it, right?
Yeah, even any electronic.
That's the different reason.
Landing because they use
No, but no. The reason for that is not actually navigation. The reason why I turn off is because people want to focus. So the largest chance of crashing is during takeoff or landing. So if you're actually listening to music or on your whatever playing, taking off, and the thing crashes, and somehow miraculously you survive.
So whatever reason, right? So forget it.
You get out of it.
I guess they didn't want to spend the money to shield me.
If I'm gonna die, I'd rather be the shield navigation.
So anyway, so whatever the reason is, right? Whatever the reason one of the reasons they give is if you turn on your laptop, then your aircraft is going to fall off. This is anecdotal evidence, right? This happened once in a flight, kind of fell 2,500 feet or something, right? I couldn't figure out what exactly happened or when it happened, but whatever, right? But airlines would like to go to that model because they have to carry these cables, and cables are heavy, and heavy cables means more gas, and more gas means I don't know what more gas means. Cost to whom? But
to the airline.
That's what the taxpayers.
yeah, that's what you would think, right? But apparently that's anyway. So that's a different story, right? My theory on airlines is if an aircraft is fully packed, then they're losing money, right? Like anytime you fly on Delta, all the seats are fully packed most of the time, and they're losing money, right? So my theory is the only way they can make money is when people sit on the wings and fly with them, right?
What is the awesome? What is the
load factor?
Well, yeah. What is the desired capacity of people?
I think 85% load factor is supposed to be profitable for profitable airlines.
So why do they oversell flights?
But Delta usually runs at seemingly much more than that, right? I mean, So anyway, that's a topic for a different class where airlines, so it saves gas, but what that means to anybody, I don't know what that means, right? But still, so they could do some of these stuff, but they are not doing this because of cabling and other stuff, right? But since it's a smaller scale system, they can actually go both ways. They can actually make it such that they don't have to scale, right? Or they can do smarter stuff. If they're going to go with wireless or something, they have to be smarter because the bandwidth is limited. But if they're going to run fiber optic cable from your TV monitor to the storage, they don't have to be any more scalable than the number of seats, right? So they can get a whole bunch of stuff. So anyway, so that's all the stuff that we've been promised, and the other stuff is the content distribution networks, which are supposed to be out there. Like Akamai. If you came to the lecture like a few weeks back from Fabian, they're talking about Akamai and stuff, and they would give the contents to you, and sort of similar to what Chris was saying in terms of the what do you call head units? You said that Comcast has some head units, right?
They have some kind of a central server, but just when you say you want to see something, start streaming it.
Yeah, so you probably contact Comcast, and then it probably tells your local something to serve contents to you, right?
And whenever you're trying to talk back and forth, it's very, very slow.
Yeah.
Once you start streaming, you're fine. But their latency is low.
Yeah, I have no idea how they actually do that. So anyway, so that's sort of what we want to get to, because that's the bigger stuff, right? So in terms of the serving a media server, YouTube is a media server too. It's serving everything through Flash, and YouTube sees a lot more requests, lot more scalable stuff than the Comcast and stuff. And how do we manage that? The book talks more about the disk layout and disk scheduling and how to place these disks and everything, which was concern, which is still a concern. I'm not sure how much of it's a concern for going forward, right? So for example, your iPod, right? Your video iPod or something, right? It has a little hard disk in there, so it has to figure out how to move the head, how to schedule all this stuff so that it can give you the video when you want it. How many of your video iPod have seen one? So what did you think of the playback? Did you notice any kind of a slowdown or?
My main impression was that it was way too small. But I can actually see that.
So what was the general impression in terms of these things? Right?
There's some latency when you start and stop it.
Once it starts, it's
What's playing?
So some of the stuff that we'll see is trying to show how to place these contents on the hard disk so that it looks like things are flying, right? So how many of you know what kind of file system that the iPod has? Yeah. So it can be either FAT 32. I mean the regular DOS are regular Mac file system, right? Which kind of goes against what I'm going to talk about, which is like how to place these, so you are formatting those hard disks to be any old Windows files, the FAT32 or Mac file system, right? So you want to guess how they're able to achieve good feedback, good playback with a normal file system or yes, playback buffer, right? So they call it skip protection, right? I think the iPod has a very huge skip buffer, right? I forget what the number is, but it's pretty big, right? That essentially means that if you can jump and hop and everything with the iPod, and it's playing out of the memory, right?
Why don't they use like a log file system or something where everything's more sequentially?
That's the $1 million question, right? So do you want to be smart? So that's the theme of this course. So I don't want to talk about this class as this is the technology that that's cool, right? So the question is, do you want to be smart and do all the stuff that we're gonna look in the next few slides, log structure, file systems, and what have you? Or do you want to be dumb, have lots of memory, cache everything, read ahead, and whenever you can, read everything, and then play, right? So what is the way to go, right? I'm not taking sides. So the next few slides I'm going to talk about is the how to be smart. How to be smart such that you can do all the things we'll see. The iPod model is don't have to be smart. I mean, just have such a big buffer that everything goes in there. Yeah.
Well, a question I've always had is, if you looked at the gone actually into the hidden folder on your computer and seen how iTunes organizes the folders. It has some weird naming scheme.
Yeah.
It's like the folders will be like A0, A1, A2. Like I don't know if it somehow organizes the music based on a certain scheme when it first loads it on there. Or
on the iPod or on the here?
iPod.
Oh, on the iPod.
It's not. It doesn't look like your iTunes.
Okay. Okay.
Which everything's organized by like artist, album.
Yeah.
I mean, it might be, but it might just be a shorthand.
Yeah, I mean, they would probably hash that.
But when you go into the folders, it's not how it is.
Okay.
So I don't know what they're doing.
They probably hash the directory names to numbers, right?
I'm wondering if they organize maybe the songs on a certain.
Because you're not supposed to look at that anyway. So what they do is their business, right?
Yeah.
I mean, yeah. So I mean, they can do whatever, right? But essentially, what they're not trying to place these things in a nice fashion, rather use, brute force, right? So if I have a 5-minute playout buffer, then I don't have to worry about it. I think they have a very big number. I forget what the number was, but you heard it for the audio, sir. Yeah.
But you can still lay things out in a nice fashion.
Oh, yes.
I mean, you can still lay it out sequentially, which is essentially what the advantage of a log structured file system would be. And you could still need a buffer when it was laid out sequentially. Because if you can't read the disk, you can't read the disk because of bumpiness or something. Like, it's not like having it sequential fixed the problem of moving it.
So that's the middle point, right? So you can be very smart on what you lay out and then have no buffer at all. You can have a middle ground where you do lay out smartly and you need buffer. Or you can go the other extreme where you have so much buffer, it doesn't matter, right?
But what I'm saying is, laying it out smartly doesn't really solve your buffer problem when you're talking about something that's moving. You could not be able to read that.
Oh, you mean like you may still want buffer?
Yeah,
right.
I'm saying it doesn't matter how intelligently you lay it out. If you're talking about something that's moving around and it's going to be bumping, still you're going to need a buffer.
Yes. But the point is, if you have so much buffer that you don't need to do smartness, is what the stuff is. I think it's important to look at that because I don't want you to get out of this class talking about pedantic stuff and then people say like, oh, it doesn't matter because my video iPod does not do any of those, right? It's good to know what they are, what people did. The unfortunate or fortunate thing is all this was like when I was finishing my PhD like 6 years or so back, right? So it's not like I'm talking about in the other operating system class where you can say this is how they were doing it in 70s and stuff. This is how it was being done when you guys probably went to undergrad, if you're in grad school, and so on, right? So one of the important stuff that you need to remember for the streaming servers is the objects are large. So you need to do something about the file system. Your file system or storage has to account for large objects, and they also have real-time requirements. So you need to make sure that they're streamed at the right time. One of the stuff that you would try to look at is, I can't just shove a lot of data into you because you may not have lots of buffer space. Now, of course, if you have like iPod where you have a lot of buffer space, then some of these concerns go away, right? But essentially, I can't just send the stuff to you, right? But in the newer model, those are changing because like the memory is getting cheaper, disks are getting cheaper. So one of the things that people talk about is when you buy a new video iPod, right? What if they actually pre-populated with all the movies that are out in the collection or something? And maybe not in an iPod, but in other stuff, right? Like your Comcast thing. Comcast essentially puts a 300 gig hard drive on your home, right? And those are fairly cheap, right? They actually send all the content to you overnight, and so it's all populated, right? And that's not a bad model. I think even the Microsoft Zune is supposed to do some kind of a, it comes with a set of songs already on your player, right? And that's a form of buffering too. I mean, I'm just shipping it from the factory with all the songs preloaded. Live streaming is a different beast. I'm not talking about live streaming because live streaming gives you none of these benefits, right? None of the benefits of buffering helps you because, so there are two kinds of live streaming. Live streaming of a TV is one thing. Live streaming of a chat or talk is another thing, right? Of a TV program, if it's a few minutes late, you probably don't really care. But if it's a video, if it's you're watching the Notre Dame football game and it's few minutes late, you don't care if there's no other way for you to receive the content. But if you have radio, which is streaming stuff to you very fast, and you have this TV, right? You may have problems with those. And the way the model that you develop may include a two-step retrieval process where you actually go and say what content you want, and the content server says, here's where you should go and get your content, and then you go off from that, or you can do it without you knowing about it, right? So in terms of, so when you people who did the QuickTime broadcaster for the first project, right? You created a file, probably you created a STP file, right? Did you guys look into the STP file? It's actually a text file, right? It basically would tell you where you should look for the video stream, where you should look for the audio stream. Did you ever look at this?
What's an STP?
Session Descriptor Protocol, I think. So I'm doing on a text thing. If you look at one of the STP files, it essentially would have a bunch of descriptors like this, right? Will tell you, I think I was using this IP multicast address for something, right? Of course, it's in a different character set, so you can't really see what these are. But essentially, it tells you, if you open the file, it says, for movie and audio, these are the parameters, but go to these servers to get the contents, right? So it's essentially giving you where you should go. It's not redirecting you on anything. So if you click on the file, it says go, you as a client should go and find these contents, right? See my mouse, okay. And that sort of that may be kind of happening with your Comcast too. You may not notice it, but when you say purchase, it may tell your browser to go look at your local head unit. And one of the textbook makes a point that one of the biggest components on your videos, media server is the disk, right? You don't want to store it on a tape because tapes are not sequential, random access. So you want to put it on a hard disk. And how do you place these things? Where do you keep these things are fairly important, right? And this was also unreliable, so you may have to have RAID going forward. So many of these things you would have learned it in your in the OS class in terms of this have sectors and tracks, and how do you keep these sectors? How do you keep these tracks affect what kind of performance you get, right? And sectors being what they are in a platter, reading stuff on the outermost rim is faster than reading stuff on the innermost stuff, right? Because you have to wait for the disk to spin to a certain extent. If it's on the furthermost end, you don't have to wait for that much time. So there's a lot of work trying to place these contents at the right set. If you keep the most popular stuff, the direct entries in the middle, the contents at the end, right, and the least recently used stuff towards the center, then you can kind of do a sort of quality of service stuff. So whatever you predict will be used a lot, you place it at the end. Whatever you want, you don't really care, or you don't think would be used a lot, you tend to keep it in the middle, right? So the book talks about a lot of the work done on depending on what kind of a disk you have, what kind of a recording you have, where you should place this content so that you get good quality for different stuff. And he also talked about contiguous storage or non-contiguous storage, whether all the blocks should be placed close to each other or they should be further out, how sequential they are, notions of log structure file systems, and what have you. And going forward, going to the notion of reliability, you have the notions of RAID, which you'll probably cover in operating systems core class in lot more detail. Essentially, you have the main things you need to worry about are the RAID 0, 1, 5, and 6, right? RAID 0 is basically striping. RAID 1 is mirroring. So each one of those RAID levels, when you study in operating system class, you talk about what it means for small reads, and so on. And those things apply here. So if you want to have RAID 1 where it's mirrored, right, I can read from any one of those disks. So if I have a media server and I can read from any one of those, I have a replication factor where I can get the disk going. So my disk arm is no longer a bottleneck, right? If I have two users who are requesting content, right, then I can use one of the disks to serve one user, another disk to serve another user, because I know both are mirrored and they're the same content. Whereas if you use RAID 5, it's more efficient in terms of storage, but you have to read the parity disk, and they could be a bottleneck. So those things affect how things are placed and where things are, right? So there's a whole discussion on the RAID concept, and I think the RAID concept is still valid for going forward in terms of newer stuff. In terms of creating the sectors and tracks and stuff, right? I think I said that in the OS class, and the times for those are long gone, right? Because modern disk is fairly complicated. Modern disk actually has its own buffer, has its own little firmware which places, moves things around. So what you think of sector or track or whatever from the OS level may not be what the disk is actually doing, right? So when they manufacture these things, if the disk detected some sector was faulty, you would remap it and never tell that to the OS. So what the OS knows as tracks and sectors may have no relation to what the hard disk manufacturers are doing, because the interface between so the disks are becoming smarter and smarter. The interface to the disk is still the 70s or 60s technology, where you assume that the disks are dumb and then do exactly what you tell them, right? And most of the disks you buy have like 16 megs of cache anyway, so they can do this rearrangement. And that's why I gave you this paper, because they were talking about changing the interface so that you tell the disk, store this block, and it figures out where it should go, right? And where it go will not matter. Whatever we're studying here may not matter, because you can say it should go on the outermost cylinder or innermost cylinder, but the disk will decide what is best for the way it is set up, right? The way it's set up and where the hardware works. Well, actually, I finished with the RAID. There are more complicated schemes that you can think of. In terms of if you think that mirroring is good, RAID 5 is good for something, then you can have combinations. You can have RAID 5.0 or 6.0, where you have striped RAID. So you try to have 2 or 3 different RAID levels, trying to get the benefits that you want, right? In terms of small reads or small writes and what have you, right? And there are more complicated factors that people talked about, where in a RAID 5, remember, you have to do a parity of all the disks into the parity sector. You could think of having few of these disks forming its own parity, rather than having all of them do the stuff. So depending on how these variants, you can try to get the best of both worlds, right? So if you want to have parity but don't want to wait for all the disks to be involved, then you can have these variants which can give you the benefits. And again, the goal here is you try to look at what the disks are, where their bottleneck is, and trying to leverage that for our media, because we know that there are a lot of objects that we need to serve, and we know what the next object will be, right? If you're looking at a traditional media, it's just a sequential access. So how do I place these things such that I can prefetch them and still get good performance and still use the disk performance, right? And that's what the book talks about. Right? Make sense? And actually, this is one of the things that I thought I fixed it, but I haven't, right? We talked about RAID, and then it goes back to talking about how, where to place it on the disk and stuff, which I think logically should have come before that, right? So essentially here, we went through this in the OS class, right? Where you talk about the scheduling in terms of scan, C-scan, how to make sure that the disk COM does not do anything bad, right? So the notion of first come first serve is if I make a lot of disk requests, first come first serve says like whatever requests come, I'll move the disk head to wherever that should be. Shortest seek time first will try to go from sort the remaining requests based on the seek from the current location, right? The problem with that is it tends to keep the disk moving closer to the center, right? It doesn't go to the end because you're likely to see all the requests closer in the center, which means that whatever is stored at the towards the edges may not get called often, which means that your quality of service may suffer. All the objects on the side may have to wait for longer. So you have variants. One of the variants is the scan, where the disk kind of keeps going from the innermost corner to the outermost corner and back and forth. So it gets sorted so that when it's going on its way from the innermost to the outermost or outermost to the innermost, if a request comes in, then it gets served. Otherwise, you have to wait for the disk to come back to you, right? So it's fairer, but then you have these, you have to wait for a little bit longer. Then you have the notion of a C-scan. So again, I'm regurgitating whatever you learned in the OS class in terms of what the benefits of these different policies are. And some of them are fair, and some of them are, gives you can give a bounds on how long you have to wait, and that's the one we are worried about. How can we give a bounds on how long we wait, such that some applications don't stop, some media streams don't stop. So the media community has two variants of the scan algorithm, again using the real-time EDF algorithm, right? Using a scan where you keep the head going back and forth.
Really?
Earliest deadline, right? So whichever has a deadline, you violate the scan principle, right? Scan goes from inner to outer to inner, and if you have an object which has a deadline, then you change the stuff, and then you have variants of that. Have multiple groups, put streams into different groups, run scan within these groups, and so on and so forth, right? But the point that this paper and all makes is you can do all this stuff because you think that you know where the head is and where the disk is, but the disk manufacturers are going in a direction where they don't want to export all the stuff to you, right? They actually don't export all this information to you. You cannot assume that sectors and tracks mean certain things, but the real disks haven't done this in a long time, right? You can be really smart and do all the scan, but in reality, so what really happens is you think this is a sector and tracks and all those things, right? But the disk manufacturers may have decided that for whatever reason, if it's inside, right, they can't really place all these sectors like close together, right? So they may have decided that this sector doesn't exist, this sector doesn't exist, right? Because they couldn't get the disk arm to do what they want to do, right? That you won't know at the OS level, right? The other stuff may be that this was trashed, so they remap this to something over here, right? So this knows how to get the contents from where it has to do, whereas you're trying to optimize all the stuff, and you're trying to, because you're assuming that this is still here, whereas it was remapped. You're assuming that the disk is uniformly this like nice round circles with the record player kind of thing. But the disk manufacturers never promised you that the disk will look just like that, right? And so when you have a 16 meg cache here, right, the disk can get all the requests, reorder them the way it wants, and then send them off to disk. So you're trying to do something, disk is trying to do something else. Usually the disk is right, not you, because you don't know how the disk is organized. Right? So their model is, give the object to us, we'll figure out how to do it and stuff, right? But again, this is still a pretty popular pedantic stuff, and I'm sure, at least in the undergrad OS, we went through that, and I'm not sure how the grad OS is dealing with the topic, right?
Is there a way to interface? Is there a way to access the model?
No, the disk manufacturers don't want you to have that. There's no
so like if you run, I know all this is a problem, but I'm just curious. If you run defrag on a Windows machine, does it? So it's really not doing anything.
No. I mean, defrag. Okay, defrag never. I don't think defrag ever did anything, even in the ideal model, right? What is defrag? I never.
Essentially, it's making sure all the files are in a continuous.
I know, but what does that mean? So assume that the disk is none of the things I talked about exist, right? Assume that it's still the round model, right? No remapping
Instead of
analysis.
having a part of the file on the third ring and the second ring and the first ring and all split up, it just makes sure that they're sequential.
Yeah, no, but like, what are you trying to do?
If you're going to access the whole file, it would be faster.
Yeah, so okay, if you're trying to access this file, if you're trying to access the 3 blocks in order, right, without interleaving processes coming in and changing these requests to the disk, you expect defrag to work, right? So if you're working on a machine which has no multitasking, only one task running, and it's reading all the files, it's not doing anything else, then you expect defrag to work, right? But if you have multiple tasks, right, and you have did some defrag and you're requesting these 3, right? There's another task which is requesting another file like this, right? OS never promised that your 3 requests will not be interleaved with the other 3. Right? I mean, you're doing a read operation here for 3 blocks. This is doing read operation for 3 blocks, right? They don't have to be interleaved or whatever in any fashion, right? So even if you defrag properly, if you have multi-user things.
But that doesn't, I mean, just because there are instances where it won't help you doesn't mean there aren't instances where it
the other stuff is you're making this into a long line of things, right? So it may so happen that 1, 2, 3, 4, 5, 6, 7, right? 8 could be here, right? So when you do a defrag, you assume that 6 to 7 and 7 to 8 costs are the same.
Yes, but at least you would know that they're one track off as opposed to, I mean, there aren't really 4 tracks, right? There's like hundreds of them.
So my point is, there may be cases where you really win out, right? But I'm not sure that if there's any study which shows that you always win out, right? That defragging actually makes a big difference for a lot of users, right?
On the average, though, it should never make it worse. I mean, obviously, there are individual cases where it can make it worse, but if you average them out over time, it should never make it worse.
Placebos can argue the same thing. A placebo should never make you sicker.
Yeah, I actually think this is more of a placebo effect, right?
It's not human psychology or whether you get something you feel better. It's a freaking computer.
No. So if you do a defrag for if it takes you half a second, right? I would think, why don't you do it, right? But defrag usually takes like a long time, right? On the old machines, when you had half a gig disk or something, then it was reasonable. But if you have like a 400 gig hard drive, right, it defrags forever. But I'm not really sure if it makes much of a difference, right? But
I guess my point is you don't really know where these blocks are, right? And so literally defrag isn't really even defrag. Like ignore whether or not defrag is a good idea.
Okay.
But if you don't know where the disk is actually putting the block, then even the theory of defrag falls down.
Yes.
Right?
Yes. I think theory of defrag falls down when you have multitasking.
No, but I'm saying I don't know if I think that's true, but I do think that if you literally don't know that this block is actually where you think it is, then obviously the concept of we're going to order the blocks, but you're not really ordering them because the disk is now doing its own thing and ignoring you.
Yes, that's one of the reasons why defrag doesn't work, right? The other reason is if the OS does prefetching, then defrag may or may not matter, right? So there's many reasons why defrag is a bad idea, right? This is one of them, right? And haven't done this ideal model, I don't think, in a long time, right? Because I don't think the disk manufacturers can manufacture this idealized fashion that you really want. I mean, you want these things to be nice little circles and all those things. And so actually, there's another paper which I don't have here, right? So the difference in tech. So this is not related to multimedia, but sort of related, right? So ever wondered why a 88 disk and SCSI disk? One 88 disk have a lot more storage than SCSI disk, right? 88 disk you can buy a 750 gig hard drive. A SCSI drive is like what 250 or 300 gig, right? And then 88 disk you can buy like 300 gig for like $80, and SCSI disk the same would be like $1,200 or something, right? Ever wondered where the cost difference and stuff comes from? Yes. They have more intelligence, but also they have. So if you want something which is really tolerant of any kind of mistakes on the hard drive, right? I mean, if you want the disk to really spin at the speed that you want and everything, those things add cost, right? So the one way to cut cost is to kind of make the disk do sort of non-optimally like this, and then have firmware which kind of fixes all the stuff, right? If you wanted to really do this like perfectly, like like a circle with like all these lines kind of thing, right? Then you have to have precise mechanisms which push up the cost and bring it more to the level of SCSI, where you have a lot more firmware there, but also the components are a lot more precise, right? But when you're buying 88 disk or something, right, they do a lot of stuff inside the firmware to offset all this stuff, right? So if you demand that it should be like this, then the cost of the hard drive will go up, right? So they never promised this, and some people, most in academia, tried to figure out how to lay these things and get some performance and stuff. And it did make a performance difference, I think, in late 80s and stuff, right? Where the disk had so much, the disk could not afford to have memory inside, right? So they couldn't do reordering inside even if they wanted to, right? So you still got bad performance, but it was not doing any reordering. Now it can do reordering. So even if things were the way you want it to be, this can decide that that's not the way to go. You can reorder things on the fly, right? And they should. I mean, why shouldn't they do that, right? So the newer trick is to actually have an NVRAM up here, or some sort of a flash or something into your disk, right? That is what Seagate now is trying to go to, right? So when you write content, it doesn't actually go into the hard disk. It actually goes into they have a flash in here, not big, 256 meg or probably a gig or something. And that captures all the stuff, and then happens from there, right? 256 is plenty for most of these operations. You can actually rearrange these things. So the future is all the things I'm talking about here is irrelevant, right? But you should know that this is where people talk about. Yeah. So I'll finish. Yeah, this paper, right? So if you have these things, you need to have admission control. So depending on what kind of a media server you run, if you're too overloaded, you should kick people off, right? If you're YouTube, you don't really care. You don't care if people get bad quality service because you want as many users as possible. But if people are paying for them, then you want better quality, right? So I'm not sure whether Comcast really cares about throwing people up because you said you're not paying for it, right? But if you paid for it, then Comcast may think about it. I'm saying they may care about it because dealing with the cable companies, it doesn't seem like they are saying, oh, I'm sorry, like you paid, so I'm not giving you service, right? But theoretically, that's a possibility. The other nice thing is like in terms of replication, once you have these disks and stuff, having replication static or dynamic on the flow, there's a lot of work done trying to make popular content more replicated. And in that context, one of the papers in SOSP05 I thought is pretty neat, from Kang Shin's group at Michigan. They were essentially using the Linux ext3 file system where all the free blocks, they use it for replication, right? So they know that most of the disks are free. It doesn't show up on your anything. Your disk still looks like it's empty, right? But whatever is free, right, they just leave these contents on the free space. So if you happen to recover the space and then write over it, so be it, right? But otherwise, your disk, essentially your whole disk is used either for contents or for replication from the contents on your file, right? So the more popular items will get replicated a lot inside the hard disk, right? It doesn't take any space because you're using the free space, which is free, but you can store the contents there, and that's a pretty nifty paper, right? Anyway, so what?
Why would you replicate if you can override an instance?
Oh, so you're replicating for performance, right? So if you overwrite it, then actually, so all the scan and all those things, right? You can actually do a better job, right? So if it's replicated, then you don't have to scan all the way through because it's closer to you, and you're doing this for performance, right? So in the worst case, you're no different than the previous disk. In the best case, it can actually be much better. It's pretty nifty because it's, you get that, I don't know how many you've read the paper, right? But if you read the paper, you go like, that's cute, right? Again, it still uses the notion that, you know some of these things, right? So that still is there because you know that, moving this replication helps you in some scan. So that's the what the textbook talks about in terms of, how you place this hard disk and how do you achieve performance. And we'll continue with this in the next lecture on what it means for file systems and stuff. I have a few more. I think at least one more slide. And what I think is happening in the future, and I wish the textbook actually talked a little bit more about these kind of stuff, but it doesn't, right? So the idea here is what we mentioned, there's so much remapping and stuff happening that you shouldn't really be doing this. If you talk to the Eric Idle, one of the authors on the textbook, right? He doesn't like you messing with the Seagate stuff. I mean, he's the research something in Seagate, right? CTO or whatever, right? They don't like you to mess with all this stuff because they would do anything to let this die, right? Because this interface is messing with them because now so if you're Oracle, right, and you're doing all the stuff, and then you're saying, I'm not getting good performance, and that's Seagate's fault, right? So if Oracle says, don't buy Seagate, buy Hitachi because Hitachi disks are dumb. Seagate disks are smart because they're doing something internally, but we're trying to impose our smartness, which their smartness doesn't make sense, right? So Oracle tries to make it smart, and so they would recommend to their customers, buy Hitachi because it's dumb, because we are smart, we can make Hitachi work better, kind of thing. So it's a race to the bottom. So they would like for this to go away, so consumers won't mess with it, right? So they would rather, they don't want to hear it. They have to still play this game because there are big customers who are concerned about this stuff, right? So if you talk to them, they would passionately argue that you should really leave this stuff to the hard disk because hard disk knows all the stuff. Hard disk is not one thing which is being shipped to all the things, right? So whenever you build a new hard disk, it figures out what its status, it figures out how much space it has and all the tracks and everything. So it maps itself, it's evolving, it has a little operating system in there, right? And they're like, we can do a lot more because we know how these things work, we know how these motors are, what's the latency on these motors, when to start, when to stop them, all those things. The OS will never know that because OS is not designed to deal with all the hardware intricacies, plus the timing issues. These things have to happen at a very low latency. So there's no way we can push this off to the OS even if we wanted to, right? Just get out of the way. Just don't mess with the stuff, right? So if you ever get a chance to talk to Eric, he'll tell you why this is a bad idea. The other thing that we'll actually read a paper on is the stuff we talked about in terms of media serving and all those things, right? People rarely run media servers off of a single server with the single hard disk and stuff. You're trying to talk millions of, thousands of machines, right? So, for example, YouTube, right? YouTube does not have one server serving all the stuff with one single disk or 10 single disk or something. They're having lots of servers. So, how most of this stuff happens is, it's probably more in the graduate operating systems class. Essentially, you have a server farm. You have a data center with thousands or tens of thousands of machines, right? With multiple different customers. So you have a Amazon farm, server farm that Amazon is renting out to a whole bunch of other people, right? So YouTube, let's say, they get a certain number of machines in that pool, right? The preferred way to run these applications is using a virtual machine incarnation. So essentially, you can say, I want 1,000 servers. So they give you 1,000 virtual servers, which get put on different machines, and each of those machines can run instantiation of your media server to give your client some service, right? So what you really want to make sure is, how do you give quality of service to these virtual machine stuff, right? If you don't know what they are, there's, so if you're using the new Macs, that's the Parallels or VMware kind of stuff, right? So essentially, it lets you run another operating system inside your own operating system as a software thing, right? It looks fine for the most part, except for timing stuff. You're still sharing some of the original hardware. So there's interactions there. How do you make sure that interaction does not affect your quality of service? That's a real big problem. That's a real big challenge, right? The companies would like to instantiate these things on the fly, right? They sell this VMware players kind of thing. So they would say, there's a machine running there. Just go start this stuff, start streaming from there, right? That works for like web server or something. Doesn't quite work like that for streaming, because there's a lot of cache and lots of other effects which affect this stuff. Anyone can, who can solve these issues in a nice fashion, that's a big challenge out there. How to make these things quality aware, and how to measure the server capacity. That's the paper we'll read. And it seems fairly simple. And Lucy, who's the author of the thing, she's been working on that for a long time. Essentially, you're not trying to figure out what's the capacity. You're not trying to figure out what's the capacity of the Amazon data center, right? Because that's pretty big. But you're only renting 1/10 of that, right? How much capacity do you get for your application? How much does YouTube get in this model where Amazon owns 10,000 servers and YouTube only hires like 1,000 servers? How do you make sure that how much is being serviced? What's the service level agreement that you want to have, right? Where how do you place that? How do you make sure that these virtual machines are giving you this service? Is some of the things that the major companies worry about, right? We'll read one paper on the server capacity and stuff, and the others may or may not be may not be something that we have time for, right? But those are things that would have to be solved. So, do you think these are challenges for something like YouTube? I think YouTube has its own set of servers, right? But eventually they will have to run these clusters, right? You think that YouTube and Google and all like worry about these stuff? Yes.
Probably not. It's only Flash and it's free, so they probably don't care.
Yeah, I don't think it's only Flash matters, right? Because Flash would still be able to do all this stuff. But I think the free part is the key, right? So if you're free, you don't really care, right? I'm sure nobody will complain. And if you'll really complain, so you still want to have some quality of service, right? So if I find a cute clip and I send it to the class, if none of you can reach it, right? Then I'm not going to use YouTube. So their quality of service is a lot more looser. I mean, it should be, if you can see it, sort of you're fine. You're not complaining too much because you're not paying for it, right? But there are the other applications which can come where these sort of things matter, right? And we haven't seen too much of those, I think, But what Lucy and their group in HP works is not for the general internet public who are getting these things for free, but for paying customers, right? So can you think of a paying customer who would care about video quality and who's a big industry out there which does streaming video? Yes.
I know this is an old example, but Victoria's Secret had an online fashion show. Wow, it was a big deal. They paid lots of money to do it. And they were really mad because a lot of people couldn't get on the scene. The whole thing was a little while.
Yeah, so advertisement.
A lot of money to do it. They were mad because they.
So advertisement thinks of expensive stuff, right? You're not probably going to see the same products which is being sold in like Walmart or something, but big Victoria's Secret or BMW or something like that, right? So they really care about this stuff. What's other big application that would really cares about quality of service? All the stuff we talked about is one industry which really wants high definition in good quality.
Sports and photography.
You talking a lot about like medical, like trying to perform.
Anything goes. Anything goes. I'm saying, what's the big? Who's saying from both?